Today's lesson objective, students will prove triangles congruent by side angle side and hypotenuse leg. So we've got a couple of definitions we need to talk about. First is the definition of an included angle. An included angle is an angle between two adjacent sides. So if I look at my figure, triangle ABC, angle A is the included angle for sides AB and sides AC. Angle A is the included angle for AB and AC. Okay, so it's just the angle between the two sides. A leg is a side in a right triangle that's adjacent to the right angle. It's a side adjacent to a right angle. So in my figure here, I can see that XZ is a leg and ZY is a leg. And then finally we have the hypotenuse. You've heard this one before. The hypotenuse is the side that is opposite the right angle. Okay, so on my right triangle over here, again, this is a leg, this is a leg, and finally, this side is the hypotenuse. Okay, so talking about side angle, side congruence. Two triangles are congruent if two sides and the included angle between them are congruent. And so what's important to remember about side angle side is that the congruent angle has to be between the congruent sides. And you can see in the figure here that I've got these two congruent sides and then the congruent angle is between them. So it's side angle side. So if you're going to use that in a proof, you would have to say that RS is congruent to UV, angle R is congruent to angle U, and RT is congruent to UW. Once you have those three things in a proof, you could then say triangle RST is congruent to triangle UVW by side angle side. Another theorem we have for proving congruent triangles is hypotenuse-leg. And so hypotenuse-leg can be used only for right triangles. And before you use it in the proof, you must state in the proof that it is a right triangle. Okay, so before you can use hypotenuse-leg in a proof, you would have to say that the two triangles are right triangles. So how that would look is you would say triangle ABC and triangle DEF are right triangles. And then you would have to show that the hypotenuse and a leg is congruent. So in this case, AB is congruent to DE. That's my legs that are congruent. And BC congruent to EF. Those are the hypotenuses that are congruent. And so if you have all of these things in your proof, you would then be able to say triangle ABC is congruent to triangle DEF by hypotenuse-leg. Okay, so far we have side, 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 side angle side, and hypotenuse-leg. One thing you should know, in geometry, there are no donkeys, so there will not be any angle side, side. You cannot use that to prove triangles are congruent. No donkeys. And the other thing that you will not see to prove triangles congruence is there is no angle, angle, angle. So we say there are no tow trucks. And just in case you think you can do this, you cannot have SSA either, because after all, that's just a donkey looking in the mirror. So, no donkeys looking in the mirror either. Okay, no tow trucks, no donkeys that are narcissistic. Okay, so we're going to use side angle side in a proof. We're given that segment BC is congruent to segment DA, and we're given that segment BC is parallel to segment AD. And we're going to prove that triangle ABC is congruent to triangle CDA. So they've already given us one side that's congruent. They've given us BC congruent to DA. And so I need to show another angle is congruent and another side is congruent. Well, they told me that the lines are parallel, and they did that for a reason. So if I think about this, if I go ahead and extend out my lines and try and visualize that, that's my parallel lines, and then here's my transversal, I know that alternate interior angles right here and here would have to be congruent by the alternate interior angle theorem. And so that's what I'm going to state next in the proof. I'm going to say that angle BCA is congruent to angle DAC. And I knew that by the alternate interior angle theorem. So now I've got a side and I have an angle. I need another side. And the angle has to be between the two sides. And if I look here at my picture, I can see that they're both sharing side AC. And so I know that AC is going to be congruent to itself. I'm going to write it AC is congruent to CA because A corresponds to C and C corresponds to A in the congruent triangles. And so how do I know something's congruent to itself? It's just looking at itself in the mirror. That's the reflexive property of congruence. And that's my other side. So now that I've said I have side and an angle, the included angle, and another side congruent, I have enough information to say that my triangles are congruent by side, angle, side. We have another proof using hypotenuse-leg. For this proof, we're given that WY is congruent to XZ, and WZ is perpendicular to ZY. So that's a right angle there. And I know that XY is perpendicular to ZY. So this is also a right angle. So the two triangles that we're trying to prove congruent are WXZ, so there's WX, oops, that's X, okay, that was wrong. All right, we're trying to prove that WYZ, I just said it wrong, WYZ is congruent to triangle XZY, this triangle here. So I see that I have an overlapping side there, and so whenever they have an overlapping side, like I have right here, I know I'm going to be using the reflexive property at some point. I'm going to wait to use that, but I will use that. All right, so like we said, we've got some right angles, so that means that they are right triangles. Well, first I have to say that they're right angles because the lines are perpendicular, so that's going to be the first thing I say, is that angle WZY and angle XYZ are right angles. And I knew that because the lines were perpendicular. Perpendicular lines form four right angles. Or in this case, you could have also used the definition of perpendicular lines. All right, now that I've said they're right angles, I can say that they are right triangles. So triangle WYZ and triangle XZY are right triangles. How do I know that? Well, that's what it means to be a right triangle. If it has a right angle, that's the definition of right triangles. So now that I've said that, I notice that in my given, WY and XZ were the hypotenuses. So they already told me that the hypotenuses were congruent. So now I just have to say that the legs are congruent. And like I said, we have that shared side on the bottom, so it's going to be congruent to itself. YZ is congruent to ZY. And again, I reversed it because of how the congruence statement is written, that Y corresponds to Z and Z corresponds to Y in the other triangle. And so again, that's the reflexive property for congruence. And so now that's my other leg, or the only leg that's congruent in this. So now by hypotenuse leg, I can say that triangle WYZ is congruent to triangle XZY. So when you're doing triangle proofs, you want to look and see if there's a shared side. Anytime you have a shared side, you can be using the reflexive property. Keep your eyes open for vertical angles as well, because you know vertical angles are congruent. And of course with the parallel lines, look for either alternate interior angles or corresponding angles. Those will show up a lot of the time. And that concludes this video. Thank you.